This video lesson is all about calculating the total resistance of a circuit. Now, to calculate the total resistance of a circuit, first thing we have to do is figure out which type of circuit we're dealing with, a series circuit or a parallel circuit. So I've got two circuits drawn up on the board here. Call this one circuit number 1 and this circuit number 2. And we figure out which one's parallel, which one is series. So we have 3 resistors connected to a power source. And we can see here in number 1, they are connected one after another, which means any electron traveling through the circuit has to pass through one before it can pass through the next. And it has to do that in a series, therefore this is a series circuit. In the other example, any electron passing through the circuit, well, those electrons have kind of a choice, you can think of it that way. The electron just randomly could go through R1, R2, or R3, but any given electron does not pass through all 3 of them at the same time. So when that happens, when an electron has more than one path that it could take to get through a circuit, we call that a parallel circuit. So circuit number 2 is a parallel circuit. Now the reason we have to figure out if it's a parallel or series circuit is there's a different formula for calculating total resistance, depending on which type we're dealing with. The total resistance, we call that RT, resistance total, in a series circuit is simply calculated by adding together the sum of all the resistors in the circuit, however many there are. We happen to have 3. If you had 4 or 5, you just keep adding them. So as long as we know what the value of those resistors is, we can calculate the total resistance of the circuit. So let me just put some numbers on this. Let's say we have 10 ohms for R1, 20 ohms for R2, and 30 ohms for R3, just making those up. So when I want to calculate my total resistance, I just simply add them all together. 10 plus 20 plus 30 is equal to 60 ohms. And that's all there is to it, to calculate total resistance in a series circuit. In a parallel circuit, like circuit number 2, a little different. We have a different formula. We have 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus however many more we have. So as long as we know the values of R1, R2, and R3, we can calculate this. So let's put some values on this. Let's say that R1 is 10 ohms, and R2 is 20 ohms, and R3 is 30 ohms. So we're dealing with the same resistors we had in the series circuit, we just connected them in parallel this time. So when I do my calculation, 1 over RT will now be equal to 1 over 10 plus 1 over 20 plus 1 over 30. And, well, in this case, I don't have any more, so I don't need that. All right, so to do this calculation, there's a couple ways we could do it. We could find a common denominator and add fractions and all that. You have a calculator with you. You might as well use it. So forget the fractions. We'll just convert these to decimals. So 1 over RT is equal to 1 divided by 10 is 0 decimal 1. 1 divided by 20 is 0 decimal 05. You just do that on your calculator. Plus 1 divided by 30, again, do that on your calculator. That's 0 decimal 3 repeating. So if I add all of these up, I'll just make a little bit more room here. There we go. If I add all of these up, then 1 over my total resistance is equal to 0.1 plus 0.05 plus 0.3 repeating is 0 decimal 183 repeating. Now that's not my final answer because that's 1 over RT is equal to 0.183 repeating. Well, what we need is we need RT. So technically we need the reciprocal. In other words, we need to flip this over. 1 over RT, we just want to flip it over into RT over 1. So that would be the reciprocal. And of course, RT over 1 is just RT. Now, if we remember that 0.183 repeating is the same as 0.183 repeating over 1, then if we take the reciprocal of one side of the equation, we just take the reciprocal of the other side of the equation, which means this is equal to 1 over 0.183 repeating. Let's not forget that repeating sign when we do our calculation. So I can now say that RT is just equal to 1 divided by 0.183 repeating. So I'll use my calculator, 1 divided by 0.183 repeating. And I get an answer of 5.45 repeating. Okay, so that's just going to go on and on and on. To round this off, I need to round it to 2 significant digits. The reason I round it to 2 significant digits is each one of the values I input that was measured in the equation has 2 significant digits. So my final answer will have 2 significant digits. So that would be equal to 5.5 ohms. I round up the 5 because it's not 5.4 because the 5 causes that one to round up. All right, so 5.5 ohms. And what we can see here is that the parallel circuit using the same resistors as the series circuit has quite a bit less resistance. 5.5 ohms versus 60 ohms just by connecting them in a different way. All right, so let's take a look at a diploma exam question that uses this same basic idea. All right, so here we have 4 circuits, and the question is asking us which one has the least total resistance. So to calculate the least total resistance, well, I need to know the total resistance of each circuit to know which one's lowest. So let's take a look at A. We have to ask ourselves, is this a series or parallel circuit? This is a series circuit. The resistors are connected in series, which means my total resistance is calculated just by adding together 2 resistors, which means I've got a total resistance of 10.00 ohms. Now, C is also a series circuit, so let's do that one while we're at it. We calculate it the same way. The only difference here is we have 3. I'm just going to move this over to make a little bit more room. So total resistance is equal to, this time we just have to add 3 resistors. They're all 5 ohms. So we add them all together, and we're going to get 15.00 ohms for this one. So we already can see that A is less than C, but let's do B and D. Now these two are both parallel circuits. They're parallel because the electrons have more than one path they could take through the circuit to complete the circuit, which means we're going to use a different formula. 1 over RT will be equal to 1 over the first resistance plus 1 over the second resistance. So I'm going to use decimals again rather than fractions here to solve it. It doesn't really matter, you can use fractions. But this is 0.2. So is the other one, that's just 1 divided by 5. So that's going to give me 0.400. Now that's not my final answer because that's 1 over RT. I need to find RT, so I need to take the reciprocal of 0.4. In other words, I need to find 1 over 0.4. So RT is equal to 1 over 0.400. I'm just taking the reciprocal. Okay, I can take the reciprocal of this side of the equation, so I have to take the reciprocal of this. And this is 0.400 over 1, so it's 1 divided by 0.4. And 1 divided by 0.4 gives me an answer of 2.5 ohms. So RT equals 2.5 ohms, which is even less than either of the A or C answers that we've calculated already, which isn't surprising because we found out earlier that parallel circuits, all other things being equal, it's going to have a lower total resistance. But let's do D. Let's find out what's going on with D. We're going to do the same thing here. So 1 over RT is equal to 1 over 5.00 plus 1 over 5.00 plus 1 over 5.00, which means 1 over RT is equal to 0.200 plus 0.200 plus 0.200, which is equal to 1 over RT is equal to 0.600. Then I need to take the reciprocal. Once again, reciprocal. And if this is 0.6 over 1, we take the reciprocal of that, which means it's 1 over 0.6. So RT is equal to 1 divided by 0.600, which is equal to 1.6 repeating to 3 significant digits. That would be 1.67 ohms. And we have our lowest answer yet. 1.667 ohms is less than 2.5. So our correct answer is D.